Okay, let's just dive right into this. Welcome to today's Explainer, where we're tackling what is easily one of the most pressing and, frankly, most misunderstood architectural pivots in modern tech right now. Today, we're talking about your non-human workforce. Specifically, we're breaking down identity and zero trust for AI agents. You see, as organizations absolutely rush to deploy these autonomous agents, they're kind of just bolting them onto legacy security models, and, well, it's creating massive blind spots. So we really need to completely reframe how we think about agent identity. Think about this for a second. If you ask most security teams who has access to production, they can usually give you an answer for their human employees in, maybe 30 seconds. They check their SSO logs, glance at the IAM console, and boom, they're done. But ask them this: which AI agents have access to production, acting on whose behalf, with what permissions? And usually, you just get a long pause. Seriously, that long, uncomfortable pause. That is the exact problem we are solving today. So here's our roadmap for today. We'll start with the AI identity problem, then move to the 3 questions of identity. After that, we'll cover why static accounts fail, look at agent zero trust principles, and finally wrap up with real-world security architecture. All right, let's get into section 1, the AI identity problem, fitting a square peg into a round hole. Think of this as a massive, systemic, architectural gap that we've kind of accidentally engineered ourselves into. For 20 years, literally 2 decades, we've designed systems around the assumption that the entity making a request is either a human or a well-known, totally predictable service account. But AI agents, they dangerously don't fit into either of those boxes. They're dynamic, they're autonomous, and they're highly unpredictable. Yet most of our current identity systems are just quietly pretending that they do fit. Moving on to section 2, 3 questions of identity. Breaking down the non-human workforce. Since they clearly don't fit the old model, we have to entirely rethink how we identify them. Right now, most deployments recklessly collapse agent identity into just one single answer. Instead, I want you to frame these 3 questions as a mandatory, non-negotiable checklist for complete identity verification context. We actually need to know: who is the agent software? On whose behalf is it acting? And what is the strictly authorized task scope? Let's break each of those down. So question 1. Who is the agent itself? Now, we aren't talking about the user yet. We are talking about the agent as a very specific piece of software with its own code, its own version, and its own unique behavior. Look, if an agent gets compromised or starts hallucinating and just going off the rails, you absolutely must be able to identify and revoke that specific agent instance. You can't just slam a giant kill switch on the whole AI system and take down your entire company's infrastructure, right? Then we get to question 2, and this is where things get really interesting. On whose behalf is it acting? Most agents are triggered by a user, maybe a scheduled job or another system. The permissions that the agent wields in that exact moment really ought to be scoped to whatever that triggering identity is actually allowed to do. Its permissions should never, ever exceed the broader, and frankly usually massive, permission set of the underlying service account it just happens to run under. And finally, question 3. What is it authorized to do right now for this specific task? Think about it this way. If an agent is helping a support rep look up a customer's order history, it absolutely does not need standing access to every single customer's payment data for the rest of the session. It just doesn't make sense. Even within a single session, the agent's legitimate scope of action must shrink strictly to the exact task at hand. Which brings us to section 3, why static accounts fail. The danger of the lazy answer. So how are companies actually handling this today? Well, usually with the laziest answer possible. They use one static service account, one API key, and one massively broad role for every user, every task, and every session. To really ground how terrible of a security sin this is, just look at this quote. Doing this is the equivalent of giving every employee the same admin login and hoping application logic sorts out who did what. I mean, we all universally understand what a nightmare scenario that is for human employees, right? It just doesn't work. And yet, this is exactly what we're doing with our non-human AI workforce. The direct result of this lazy architecture is a really nasty vulnerability known as the confused deputy. Basically, a shared static service account creates a confused deputy by default. If your agent enforces per-user restrictions only in its own application logic, then literally any flaw in that logic, a bug, some edge case nobody thought to test, or a simple prompt injection, lets a malicious request completely bypass the intended restriction. It then just inherits the full massive permissions of the underlying account.
And this isn't just theoretical security theory. This is the exact pattern behind several of the most embarrassing AI agent security incidents over the last couple of years. There's no sophisticated exploit needed. It's just a gap between what the agent could do and what it should do, with absolutely nothing enforcing the difference at the identity layer.
And to make matters even worse, using a static account completely destroys your auditability. When every single action an agent takes is logged under one generic service identity, you absolutely cannot answer the simplest question: which user's request caused this? Answering that means you have to painstakingly reconstruct scattered application logs, and honestly, that's assuming those logs even exist in the first place, which they often don't.
Okay, Section 4, Agent Zero Trust Principles. Applying modern architecture to AI. Thankfully, there is a way better way to handle this. Zero Trust for Humans is built on a pretty simple premise. Don't grant broad, standing access. Verify the identity and authorize every request based on context. Well, that exact same premise applies to agents, just with a few twists. Here are the core Zero Trust principles translated into concrete implementations. First up, verifiable identity. Instead of static keys, use frameworks like SPIFFE or SPIRE, which give workloads short-lived, highly verifiable identities. Second, task scope. You want to use just-in-time credentials that expire instantly to shrink the blast radius if a session gets compromised. And third, authenticate tools. The agent really must verify the APIs or model context protocol servers it talks to using mutual TLS. That ensures both sides cryptographically prove exactly who they are.
But the most crucial shift you must make is this: stop relying on broad service identities. Just stop. Instead, you have to propagate the human identity. When an agent acts because a user asked it to, the downstream systems it calls must be able to see and enforce permissions based on that specific user's identity, usually via token exchange or delegated credentials. Listen, this is the single highest leverage architectural change an organization can make. It's also the one most commonly skipped because, frankly, it is a lot more engineering work than just issuing one shared API key. Finally, let's head into Section 5, Real-World Security Architecture, bringing it all together. Now, let's tie all these concepts into practical reality. What does this actually look like in practice for a mature, production-ready deployment? Concretely, you need an end-to-end defensible audit trail. When an agent takes an action, your logs must clearly show these 4 non-negotiable components: the human or trigger that initiated it, the specific agent instance and version that acted, the exact permission it exercised, and the downstream system that received the call. And critically, all of these hops must be perfectly correlated by a shared trace ID. They cannot be scattered randomly across 4 completely disconnected logging systems. Now, if this is starting to sound a bit familiar, well, it really should. As our source material points out, none of this is exotic security theory. It's the exact same zero-trust architecture most mature organizations have already built for human access and for service-to-service communication. We already have the tools to do this, guys. The gap is simply that agent identity got bolted on super late. It was an afterthought, implemented by whichever team managed to stand up their first AI agent the fastest.
And that brings us to our final and most important takeaway. You absolutely must treat agent identity every bit as seriously as you treat human identity. The organizations that are going to successfully secure their AI deployments aren't necessarily the ones with the smartest underlying models. Actually, they're the ones who applied their hard-learned identity lessons to their non-human workforce today. So I'll leave you with this one question to think about. Are you going to implement verifiable zero-trust identity for your AI agents right now? Or are you going to wait for a massive data breach to force the question? Thanks so much for joining me on this explainer, and I'll catch you on the next one.